Today we're going to be looking at some experiments on how to prove the shape of the Earth, and we're also going to be looking at some problems I have with the globe Earth. The first problem I have with the globe Earth model is this picture here is trying to tell us this guy staring at the North Star is staring at the same star as this guy over here. The North Star is above the North Pole, and it is smaller than our pinky fingernail from our perspective. You could look at it through a straw, and you can see the North Star at the equator. 8,000 miles apart in diameter the Earth is. So this guy standing over here can be staring through a straw at the North Star, and this guy 8,000 miles away can be staring at the North Star through a straw. Now I'm going to try to show you why this doesn't make sense to me. We see all the stars in the sky rotate around the North Star. I'll start drawing some stars rotating around the North Star these guys are looking at. See, what I think is these guys are looking into different parts of the sky 8,000 miles away from each other. But we gotta remember the North Star is 20 million miles in diameter, I guess. So that's a lot bigger than the Earth, right? So the North Star is, you know what I mean? Like, a lot bigger. So I drew another picture for you guys. Let's pretend this Earth is in wintertime and this Earth is in summertime. And these guys are both looking at the North Star. The distance from these two guys is 186 million miles away. The North Star is only 20 million miles in diameter. So the North Star doesn't cover the whole distance from this guy to this guy. So what is this guy looking at? Is this guy looking at the same stars as this guy? Let me draw some stars rotating around here for you. Does this make sense to you guys? Here's the second problem I have with the globe Earth model, is reflections on water and ice, frozen lakes, flat surfaces. Let's say this is the sun, and here's the reflection. If you put a tree here or anything, it's going to make a shadow. Even if you make a little rock here, it's going to make a shadow. So when there's curvature, 8 inches per mile, you're not going to see reflection. It's going to be blocked off by curvature. So here's another problem I have with the globe Earth. On the flat Earth model, the sun is a lot closer than the globe Earth model, that's for sure. And here's a picture of the sun seen from the North Pole. As you can see, it's pretty small. Now I'm going to show you a picture of the sun seen from the Philippines, really close to the equator, and you can see how much larger it is. So here's the sun seen from a location near the equator. As you can see, it's a lot brighter or larger, one of the two. Now on the globe Earth model, the sun is millions of miles away. You shouldn't see a difference in size change when you're from the North Pole or at the equator. Now here's an experiment on how to prove the shape of the Earth. Somebody at the equator, this guy, can set his video camera up on a level surface facing directly up in the sky, and he can record the motion of the stars for about 2 hours or so. The stars should move in perfectly straight lines, rising in the east and setting in the west. They should move up and then over his head and then start going down towards east or west, sorry. But they should only move in straight lines above the equator.
haven't slept. I think I do, but I don't forget. My body moves, goes where I will, but though I try, my heart stays still. Never moves, just won't be let, and so my mouth waters to be fair, but you're always in my head.
Another experiment we can do is we can go onto a frozen lake with two poles, stick them in the ice facing directly up, 4 miles away from each other, and we can get a 4-mile long fishing line or string and tie it to the bottoms of the poles and connect it. Good enough. And when we try to move the string towards the top of the poles, it should not move to the top of the poles, because as you can see, the bottoms of these poles are closer to each other than the tops of the poles. Never mind, the string should be close to the laying on the ice, or right laying on the ice, right? Because of the 8" per mile drop in curvature.
What do you think are the opportunities for young students wanting to be involved in space?
Well, there you go. There's our resident space ninja doing the gravity demonstration. And yesterday morning, I had my coffee in floaty ball form, and sir, it was delicious. So it's awesome.
But water is such a precious resource up here that we also are cleaning up our urine and making it drinkable, and it's really not as bad as it sounds.
Well, that's good. I'm glad to hear that. Better you than me.
Gang, we've just been handed our next mystery.
Turn over, and I sleep upside down. I can't have it. I don't have any sensation in my head that tells me that I'm upside down.